Hello and welcome. In this video, we want to introduce our tool, which focuses on task-oriented analysis of model versions and variants. Therefore, we have created a framework which can be extended with different visualizations, algorithms, and predefined workflows. We define two roles for our framework. The first role is a role of the domain expert. The domain expert defines a step-by-step workflow for a concrete use case. The workflow allows even unexperienced user to approach a problem of a specific use case in a structured and efficient way. We use profile UML state machines to define a workflow. A diagram will be specified as a state. After applying the diagram profile, we can set the ID of the corresponding diagram. A transition defines how to forward the data between the diagrams. We can define such simple things as forwarding the selection in a generic way, or we can define a special transition implementation, for example to convert data fragments between the diagrams. Each diagram is enhanced with a tree view of its corresponding data. We can configure different compositions and aggregations for the data. A composition structures the data as a tree, and an aggregation compresses multiple elements to a container node. We will now introduce those features in a short tool demonstration. Therefore, we switch to the viewpoint of a tool user. The first step is to create a new visualization session. We open the session dashboard and add each relevant model to the model manager. In this case, we have 12 different variants of an online banking state machine. On the next page, we are able to set up the tool configuration. In this case, we choose a workflow to analyze different model variants. For example, we could try to find the common base model of all variants. After setting up the algorithms, for instance the matching algorithm, we can start the visualization with a predefined workflow. In the first diagram, we want to give a brief overview about the similarities between the given models. Each node represents a model, and the distance between two model nodes is proportional to their dissimilarity. For its structure, we denote this visualization as galaxy cluster. As we can see, the models are clustered around their most common model. In this way, we could identify related and unrelated models. Now we can apply a filter to remove the unrelated models from the visualization. In the next diagram, we can create bar charts to get an overview about different parts of the matched models. For example, we can compare the two regions of our models by selecting them in the Match Navigator. Then we add a bar chart for each region. A bar chart can be divided in three types. The red bar shows the core paths which are common to all models, the orange bar shows the paths which are shared by several models, and the green bar represents unmatched unique elements. At this time, we are located in a parallel region of our workflow. By clicking the breadcrumb, we can obtain other views for our actual data. For example, we can visualize our model variants in a matrix view. The matrix demonstrates the relationship of correspondences and models. A column shows a single correspondence and the similarities of each model element as a color gradient. If we inspect a row, we can see the degree of correspondence between different models. In this way, we can find differences and overlaps between the model variants. With the previous visualizations, we can find the relevant model parts. These parts can now be investigated on the level of its abstract syntax graph. For this purpose, we create a graph-based representation of the unification of all models. We call this a 150% graph. We enhance this view with icons and informations of the underlying domain model, as well as a coloring that shows the core shared unique property. In this way, it is possible to inspect the structural context of the matched model elements. The tool further supports navigation to a previous diagram, for example to compare different results or to change a previous selection. In the Match Navigator, we can select different compositions and aggregations to structure the information and concentrate on the relevant parts. So, this was a brief overview of our tool. We have demonstrated the extensibility of the different framework components, as well as the user interface and tooling. Now, thank you for watching, and please visit our website for further information. And if you have any questions, don't hesitate to contact us.